Hello everyone. Today we are going to go through append and delete, which is a problem on the implementation section of algorithm on HackerRank. So without wasting time, let us have a look on the problem statement. So in this problem statement, we receive as input a string, and then we have another string that we should transform the first string into that string by performing a given number of operations. And what is an operation? An operation is basically either append a lowercase English letter at the end of the string or delete the last character of the string. And we know that if the string is empty, performing a deletion will actually return you an empty string. So let us take this an example. Can we transform the ABC into DEF? Yes. How can we do that? We can delete all the character in S that will cause us 3 operation, and we can add all the character in T that will cause us 3 more operation, and that will result into 6 operations. So the answer is yes. Now let us take another example. Let us take this one for instance. We have ABA and ABA. How can we transform the first one into the second one? The first thing we can do is that we can remove the 3 character here. We will have an empty string. We do remove again one character from the empty string. That will give us again an empty string, and we are at 4 operation. And after that, we can add those 3 characters. That would lead us to 7 operation. So this is another example of how we can organize ourselves to have the result with the key operation. Now, it is indeed possible to find yourself in a situation where you can't transform the S into T. So now, how are we going to approach that? How are we going to solve that? So the first thing we can say is that if the number of character, the number of available operation we need to perform is greater than the size of S and the size of T, we will always be able to have the operation because we can just remove everything here. After removing everything here, we remove the remaining one. That means we remove the number of characters in such a way that at the end we'll be able to add the remaining T. Let's say we have maybe 10 for here, for instance, 10. What we will do is that we will remove all this one. That will cost us 3 operations. Now we have 7 operations left. And then since we know that adding this will cost us 3 operations, what we can do is that from the 7 we have left, we'll remove the 3, we keep it, then we have 4. We can again delete 4 operations here, and at the end we add these 3. So if K is actually greater than the sum of these 2 elements, then basically we can absolutely be sure that we have a yes. So we can start by that, by saying, okay, if s.size is actually, not s.size, if K is actually greater than s.size plus t.size. If it is the case, then we just return yes. So we are okay with that. Now, for the rest of the operation, what can we do? The approach I'm going to use here is that the first thing I'm going to do is find the same radical. The same radical means I'm going to find the parts of the string that are the same. Starting from the first character, I'm going to find the substring, the longest substring that is the same in S and T. And from that, I know that to transform the first one into the second one is just all about performing operation in the remaining part, which is different. Is it okay for everyone? Okay, nice. If it's okay, then we can implement the algorithm of searching the same radical. So we say, okay, in same here, that I will initiate 0. Now, once I have it 0, I'm going to loop int from 0 is less than. Since they don't have the same size, there is no need for me to loop more than one of the strings. So I should loop from the minimum of s.size and t.size. Right? So from here, I'm going to say if s of I is actually different from T of I, that means this is the first character that make them different. So same, we take I, and then I'm going to break here. So at the end of this loop, I'm sure same will have the element from where the character are starting to be different. And there's one thing important you need to know. Let's assume that maybe the first character is int and the second one is int. In this one, we are going to look from 0 to 3. And you do agree with me that we will never make this. That means with such operation, we are going to find ourselves with same with 0, whereas it should be 3. So we are going to start the same with this value. That means if we never get into this condition, that means the minimum character, the minimum of the both element is actually same, is actually appearing in the biggest string. Yeah, so we shouldn't start at 0, but yeah. Now we have the same radical. What we should do is that we should say, okay, k. Now we need to remove the remaining part of the first string and the remaining part of the second string. That means if you have maybe A, B, C, T, E, and here we have A, B, D, D, D. So since this one is the same, if you want to perform the transformation, the first thing we need to do is to remove this and remove this. Is to remove the part that is not the same in the first one and the part that is not the same in the second one, and that will cause us the number of operation corresponding to the number of character. So to do that, we just need to say k. We take we remove from k the s dot size minus same, and we do the same here. We remove from here t size minus same. So at this point, we're able to remove this, and we were able to remove this, and we were able to add this into this, right? So if you are here, we need to check, okay, if k is actually greater or equal to 0, that means after removing this remaining one and adding this into this, we still have a value which is greater or equal to 0, because if it's less than 0, then it is a no. So it should be greater or equal to 0, and the k should be a multiple of 2. Why is that it should be a multiple of 2? Because if after removing this, after removing this and adding this, you still have a remaining number of operation. If it is an even number, then you can allow yourself to add any character and remove it, and add, remove, just to spend the rest of the operation. So if it's here, you just return yes, otherwise you return no. So this is how we are going to perform this operation. I hope the idea here was clear to you. Let us run this and see what it gives. So here we can get rid of the if. We can just say return here, and we transform this into ternary operation, and then we remove this. Okay, let us run and see what it gives. We don't need this. We have everything here. Let us submit. Everything green. So this is my approach of solving this. I hope you do enjoy it. Feel free to give me feedback in the comment section. If you have anything to share related to this, I will be really happy to interact with you regarding this. Don't forget to like, subscribe, and share, and stay tuned for the next video. Ciao.